Okay, I'm going to be showing you how to use the combined gas law when doing problems. Okay, I've already derived all the solutions from the ideal gas law, and this is the ideal gas law up here. Ideal gas law. I showed you how to derive combined gas law from ideals, so if I remember PV equals nRT, that's something you just want to memorize. To get the combined gas law, you see PV, N and T would come to the bottom, and then N's coming out because it's a constant, so you just put T on the bottom, so you get PV over T. 1, 1 equals P2 V2 over T2. Alright, now I'll take you through every different solution, and I could be working either side. So I'll do the 2's. So if I was to solve for P2, I want to isolate P2. So P2 equals, now I'll do my work on the right here. If I got combined gas law, and I want to solve for P2, that means I need to get rid of V2, so I'm going to divide both sides by V2. I'm dividing T2, I need to get rid of it, so I'm going to multiply by T2. And so your solution is P1 on top, V1 on top, times T2 on top, over T1 on bottom, and V2 on bottom. And that's how you would solve for P2. If I did in a likewise fashion solve for V2, so P2 V2 over T2 equals P1 V1 over T1. And solving for V2, I would want to divide both sides by P2, and I would want to multiply both sides by T2. And there's your solution. V2 equals P1 V1 T2 over T1 P2. Solving it like this and plug in helps greatly. Most students have been conditioned to throw numbers in. Numbers will get you confusion, and this will make you a stronger student if you can solve for the variables and then plug in. You'll just be doing it in a much more organized fashion. This is what usually throws people off. A bad math student will say, well, let's solve for T2, and they'll divide both sides by P2 V2. And I'll show that mistake later. The problem is V2 is on the denominator. So if I want to solve for T2, I need T2 to be off the denominator. So what I'm going to do is I'm going to invert both sides. That's the quickest thing you can do. I could multiply both sides by T2 and T1, and the old cross multiplication. Generally think teachers teach that to weak algebra students. Let's put T2 up top, and then P2 V2 will be on the bottom. T1 on invert the same side, P1 V1 on the bottom, and now you have it on the top, and then P2 times V2 will get T2 isolated, so you end up with P2 V2 on the top. So what does T2 equal? T1 P2 V2. Over P1 V1. Now, just to show you what a lot of students do wrong, if I started with combined, and this is kind of lazy algebra, a lot of students will go, oh, here's T2, I need to solve for that, and they'll say divide by P2 V2. And then they'll incorrectly say, there's my answer, which is wrong, because what does this equal? Well, when you cancel out P over P and V over V, you're left with a 1. So you're not solving for V2, you're solving for 1 over T2 equals P1 V1, T2 P2 V2, and that does not equal T2. Okay, and from, if you inverted both sides, you get the correct answer. So just a reminder not to do that. All right. From here on in, I'm going to give you some actual problems. If you do all these derivations and solve in the actual problems, I'll show you how how everything. This is a very, very easy stuff. Not too bad. All right. On the last video, I was showing Avogadro's law. V1 over T1. Sorry. V1 over N1 equals V2 over N2. That V1 over N1 is a constant, and I just wanted to point out that that constant is 22.4 liters, is equivalent to 1 mole, and that's the molar volume of a gas.